Good morning, everyone. Thank you for being here. Today, we're going to delve into a critical and rapidly evolving area of artificial intelligence, the evaluation and benchmarking of large language model agents. As you can see from the diagram, an LLM agent is a sophisticated system. At its core is an agent that leverages a large language model, or LLM, to orchestrate its actions. This agent interacts with external tools to perform tasks, draws upon a knowledge base for information, and can operate with a human in the loop for guidance or oversight. The rise of these agents has opened new frontiers, but evaluating them is a complex and still underdeveloped field. This presentation, based on our survey, aims to bring clarity to this landscape and provide a framework for their systematic assessment. So, what exactly are LLM agents? We define them as autonomous or semi-autonomous systems that use LLMs not just to generate text, but to reason, plan, and act. They are designed to operate in dynamic, interactive environments, going far beyond the capabilities of standard language models. This complexity introduces significant evaluation challenges. It's not enough to evaluate the LLM in isolation, we must assess the entire system. These agents reason, plan, execute tools, leverage memory, and even collaborate with others. Their behavior is probabilistic and dynamic, which is fundamentally different from traditional deterministic software. To make an analogy, evaluating an LLM is like testing an engine, whereas evaluating an agent is like testing the entire car under various driving conditions. The augmented LLM diagram here illustrates this internal process. The agent uses perception to understand its environment. It then enters a planning loop, leveraging its tools and memory to decide on an action, which in turn affects the environment. Our goal with this survey is to provide a systematic framework for this complex evaluation and to highlight specific challenges that arise in enterprise contexts. To structure our approach, we propose a two-dimensional taxonomy for organizing the evaluation of LLM agents. This taxonomy is divided along two fundamental questions: what to evaluate and how to evaluate. The first dimension, evaluation objectives, addresses what we should measure. This is broken down into four key areas. Agent behavior. This is about outcome-oriented performance, like whether the agent completed its task correctly. Agent capabilities. This focuses on the process, such as how well the agent uses tools or reasons through a problem. Reliability. This assesses consistency and robustness over time and across different inputs. And safety and alignment. This ensures the agent is trustworthy and adheres to ethical guidelines. The second dimension, the evaluation process, describes how we conduct the assessment. This includes the interaction mode, the evaluation data and benchmarks used, the methods for metrics computation, the evaluation tooling, and the evaluation contexts or environments. Let's start with the first objective, agent behavior. This refers to the overall performance of the agent as a user would perceive it, essentially treating the agent like a black box. We break this down into three categories. First, task completion. This is the fundamental question. Did the agent successfully achieve its predefined goal? We measured this with metrics like success rate, SR, pass at K, which considers success over multiple trials, and progress rate. Second, output quality. An agent can complete a task but still provide a poor user experience. This category assesses the characteristics of its responses, such as relevance, factual correctness, fluency, and logical coherence. And finally, latency and cost. These are critical for practicality and user experience. We measure latency with metrics like time to first token, or TFFT, and end-to-end request latency. Cost is typically measured by token usage, which correlates directly to deployment expense. Next, we move from the what to the how by evaluating agent capabilities. This is a process-oriented view that helps us understand the competencies enabling an agent to achieve its goals. We focus on four key capabilities. Tool use. This is a core function, assessing the agent's ability to correctly invoke tools, select the right one, and generate the necessary parameters. Metrics here include tool selection accuracy and invocation accuracy. More advanced methods even use execution-based evaluation to see if the tool call actually works. Planning and reasoning involves selecting the correct sequence of tools and making context-aware decisions. We can use graph-based metrics like node F1 for tool selection and edge F1 for the sequence to measure this. Memory and context retention. For long-running tasks, an agent must retain information across many interactions. We evaluate this using metrics like factual recall accuracy and by analyzing its consistency over long dialogues. Multi-agent collaboration evaluates how well multiple agents coordinate, share information, and solve problems together. Metrics include collaborative efficiency and information sharing effectiveness. Reliability and safety are absolutely crucial, especially for enterprise and safety-critical applications. These objectives focus on consistent, robust, and ethical behavior. Under reliability, we have consistency, which is the stability of an agent's output when the same task is repeated. The pass at K metric, which requires success in all K attempts, is a strict measure of this. Robustness measures stability when facing input variations or environmental changes. This includes testing performance under perturbation and assessing error handling capabilities. Under safety and alignment, we examine fairness, which is the adherence to ethical guidelines and the avoidance of bias. Harm, toxicity, and bias, ensuring outputs don't contain harmful content. This is often tested via red teaming, where adversarial prompts are used to measure the failure rate. And finally, compliance and privacy, which assesses adherence to regulatory and policy constraints like GDPR or HIPAA. This is measured by metrics like the policy violation rate. Now we shift to the second dimension of our taxonomy, the evaluation process. This describes how agents are assessed. First is the interaction mode. This can be static, using pre-generated datasets, or dynamic, which involves simulations or real-time user interactions for a more realistic assessment. Evaluation data is critical. This includes a growing number of specialized data sets and benchmarks designed for agents, such as ToolBench for tool use, AgentBench for general capabilities, and Web Arena for web navigation tasks. For metrics computation, we have three main approaches. Code-based evaluation is objective and deterministic, perfect for well-defined tasks. LLM as a judge uses another LLM for scalable assessment of qualitative criteria. And human-in-the-loop evaluation remains the gold standard for subjective qualities, though it is expensive and slow. Finally, evaluation tooling and contexts are about the infrastructure. Context can range from highly controlled sandboxes to simulative environments like WebShop, and ultimately to open-world live deployments. When we move LLM agents into enterprise environments, we face a unique set of challenges that are often overlooked in academic research. First, role-based access control. In an enterprise, users have different permissions, and agents must adhere to the same constraints. An evaluation, therefore, must account for these varying permission levels. Second, reliability guarantees. For compliance and auditing, enterprises require deterministic or repeatable behavior. Occasional success is simply not good enough for production environments, so evaluation must involve multiple trials per task. Third, dynamic and long-horizon interactions. Real-world enterprise agents operate continuously, not in short, isolated episodes. Standard short-term evaluations can easily miss issues like performance drift or the cumulative effects of decisions over time. And finally, domain-specific policies and compliance. Agents must follow strict operational rules, approval workflows, and legal regulations like GDPR or HIPAA. Future research directions. Given these challenges, where does the research need to go from here? We've identified 4 key directions to advance the field. Holistic evaluation frameworks. Current evaluations often focus on isolated dimensions. We need frameworks that can assess multiple, interdependent dimensions simultaneously, balancing competing objectives like speed versus accuracy. More realistic evaluation settings. We must bridge the gap between the lab and the real world. This means creating environments that incorporate enterprise-specific elements like multi-user interactions and role-based access controls. Automated and scalable evaluation. Manual evaluation is a significant bottleneck. Future work should focus on automation through synthetic data generation and more advanced LLM-based evaluation techniques to make assessment scalable and reproducible. Time and cost-bounded protocols. Evaluation must be efficient enough to support iterative development. We need to develop protocols that strike a balance between evaluation depth and the resources required. Conclusion. To conclude, let's recap our key contributions. We've introduced a 2-dimensional taxonomy that organizes agent evaluation by its objectives, the what, and its process, the how. We've provided a comprehensive analysis of what to evaluate, covering agent behavior, capabilities, reliability, and safety. We've also highlighted the critical enterprise-specific challenges that are often overlooked and proposed a roadmap for future research toward more holistic, realistic, and scalable evaluation methods. The main takeaway is this. As we build more powerful and autonomous LLM agents, systematic and rigorous evaluation is absolutely essential for creating systems that are not only capable, but also reliable and trustworthy at scale. Thank you for your attention.